So in the last video, you got a chance to see how we use that carbonyl carbon in something like a ketone, so how we name them and what they are. But that carbonyl carbon is actually present in more than one type of compound. It's just a functional group that is present in several different types of molecule. And the molecule that we're going to talk about now is called an aldehyde. An aldehyde is very, very similar to a ketone in structure, except that instead of the carbonyl carbon having two carbons on either side, it is actually at the end or beginning, however you want to look at it, of a carbon chain. That means one of the bonds off of that carbonyl carbon goes to a hydrogen. So this is the key difference between them. You see, an aldehyde contains a double bonded oxygen to a carbon, but is then bonded to a hydrogen. This bond is then going to connect to the rest of the carbon chain. Ketones, on the other hand, have that double carbon, the carbons on either side. And so you have your carbonyl carbons surrounded. That meant ketones could be like in ring structures, they could be in different places in molecules, but aldehydes are always at one end of a molecule and never in a ring structure. So what's going to change for us is the ending. We're going to use an AL ending when it comes to an aldehyde, whereas we used an ONE ending when it came to a ketone. The other thing is because aldehydes are at the end of a chain, they're actually also the highest priority molecule that we have seen so far, and so they get the number 1. And because they're at the end of the chain, they always get the number 1, which means we do not need to number an aldehyde. So I would never say something like 1-propanal because I know the fact that it's an aldehyde means it's in the 1 position. So you would just have to say propanal. So you can see that because of this different structure, we end up naming it differently, and that's because aldehydes do fundamentally function different than ketones. They do have some different chemical reactions and some different properties, and so we do name and treat them differently. So now that we understand what they are, let's take a look at how we actually deal with them. So this is going to be our first example, and I drew it in a couple of different ways so that I could show you a couple of different things. This is just our standard condensed structural formula, so you can see CH3, CH2, C, double bonded to O and attached to an H. And I drew here the stick formula so that you could see sometimes this might look a little bit different depending on who's drawing it. Remember, we don't draw hydrogen, so it looks a little strange here because we have our CH3, CH2, C double bonded to O, and remember there is an H that would be attached here. The other thing is some people will actually just draw the H to be clear and show that it's an aldehyde. So it is possible that you'll see this both ways, but you're looking at the same molecule, just written a little bit differently for different situations. So first thing, recognize it's an aldehyde. You have a C double bonded to an O at the end of a chain, and you have a 3-carbon chain. So because you have a 3-carbon chain, you are going to name it prop. AN to show the single bonds between the carbons, and then AL to show that it's an aldehyde. No need for a number here because we're dealing with aldehydes that always have to be at the end or start of a chain. So, simple, right? Now let's take a look at something a little bit more complicated. Okay, so here I have this molecule and we want to learn how we're going to name it. Again, recognize an aldehyde, C double bonded to O with an H at the end. So this tells me aldehyde, and so we're going to count our longest chain that includes it. So 1, 2, 3, 4, 5 carbons. So we're dealing with pent as the ending of the name. AN to show the single bonds between the carbons, and AL to show the double bonded oxygen. And now we have our 1-carbon group. So we have a methyl. Remember, we don't number that aldehyde, and so we just know that it's going to be number 1. which makes this number 2, 3, 4, and 5. So what we're dealing with here is 2-methyl pentanal. Okay, so now that we've done that, how about we try and draw one? So I'll give a name and we'll work through how you would come up with the actual drawing of it together. All right, so here we have a name. We have 2-fluoro-4-propyl-nonenal. So here we are going to break down everything in this name, figure out what it means, and help us understand. So AL ending should tell you aldehyde. So you know you have your C double bonded to O at the very end of this chain. And this chain is only going to have single bonds. So you have single bonds connecting everything, and it's going to be a 9-carbon chain. But on the 4th carbon, there is going to be a 3-carbon branch, so a 3-carbon alkyl. And on the 2nd carbon, there is going to be a fluorine. So we've got a lot going on here. And let's take a look at how we would draw it. Personally, I always find it easiest to start with the longest chain. And because I'm dealing with an aldehyde, you know what, let's start with the aldehyde over here. So we're going to do double bonded O to our C, and I'm going to draw the H because I just like to be clear about that. So we have our 1 carbon here, 2nd carbon, 3rd, 4th, 5th, 6th, 7th, 8th, 9th. So this is a long molecule. But now on our 2nd carbon, so remember we had carbon number 1, because this is an aldehyde, and aldehydes automatically get the lowest number. On carbon number 2, we have our fluorine. So carbon number 2 has a fluorine attached. And then that's carbon number 2, carbon number 3, carbon number 4, 5, 6, 7, 8, and then 9. On carbon 4, we're going to have a propyl. So 1, 2, 3 carbons. It's like a little Harry Potter lightning scar there. Okay, so I know this looks like a long, complicated molecule. I should also mention you don't have to show the numbers when you draw it. Usually most people don't. I'm just showing it to help you understand it. But we have our 2-carbon fluorine, 4th carbon propyl, 9-carbon chain with an aldehyde and single bonds. So this is how we deal with aldehydes, and I think the biggest trick here is just recognizing them and remembering they don't need a number because they're always going to be number 1. So that is aldehydes, and now that we've dealt with carbonyl carbons, our next video we can move on to something a little bit different. So thanks for watching.